Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through applications of parabolas. We're going to look at applying parabolas to real world situations. So this is the example we're going to go through. A person standing 5 meters high throws a ball into the air. The trajectory of the ball follows the quadratic equation on your screen. Y represents the height of the ball above ground in meters. X is the number of seconds. And we're going to find the maximum height of the ball and how long it takes to hit the ground. So this is a perfect example of where parabolas are useful when you throw something into the air, because it will go up, it will stop, turn around and come down, much like the shape of a parabola. So even though the question didn't specifically ask it, we're going to graph this function here. You will need to graph for these questions, so it's good practice, but it'll also make clear exactly what's happening. So before we even look at a ball in the air, we're just going to graph this function here. So it is a quadratic equation because of the x squared term, and that means the graph will be a parabola. So when graphing any parabola, there were 4 things I told you to find. The first was the orientation. So because the thing in front of x squared is negative, it's a frowny face. So the second thing is the y-intercept, so that's this number by itself. So this will hit the y-axis at 5, so the y-intercept is the 0.05. So the third thing we had to do was solve this equation equal to 0, let y equal 0. So to find the x-intercepts, we solve x squared plus 4x plus 5 is equal to 0. And the solutions for x will be the x-intercepts. So we could use the quadratic equation, or we can take out a factor of -1, so it changes the sign, changes the x squared to a positive, the 4x to a negative, and the 5 to a negative. The reason we do that is we can then divide each side by -1. And if we divide each side by -1, then I'm just left with a monic quadratic, which are much easier to solve. So now I just find 2 numbers that multiply to -5 and add to -4. So those numbers are just -5 and +1. -5 times +1 equals -5. -5 plus 1 is -4. So now I use the null factor law. Either the first bracket is equal to 0. If x minus 5 equals 0, then x equals 5. If the second bracket is equal to 0, then x plus 1 is 0, x is minus 1. So the two x-intercepts are -1, 0, and 5, 0. So the last thing we need to find, the turning point axis of symmetry. So we use the formula minus b over 2a. So here b is 4, a is -1. So minus b over 2 times a gives us +2. So that means that the axis of symmetry will be the vertical line x equals 2, and the x coordinate of the turning point is 2. If x equals 2, we find y by substituting into the original equation. Y will be minus x squared, minus 2 squared, plus 4 times 2 plus 5, which is 9. So that means the turning point will be the 0.29. Now we have all the features, we're just going to plot them on the graph. So the y-intercept was 5, the x-intercepts were -1 and +5. And the turning point was 2, 9, so it will be up here. And we know the graph is going to be a smiley face, so we just join them up, and it will look something like this. So this is the graph of y equals minus x squared plus 4x plus 5. So we're not so worried about negative values of x or y, because x was time and y was meters above ground. So we're not so concerned about the graph here. We're not so concerned about the graph here. If we just look at what's left, so what's happened, the person standing 5 meters, that's why the y-intercept is 5, has thrown the ball up. And as you know, when you throw things up, eventually they'll stop and they will come down. So this graph makes it very easy for us to answer the question. So the first part of the question, what's the maximum height of the ball? Well, y is the height above ground in meters. So here is the maximum point. And you can see at this point, y is 9. So the maximum height is 9, and because it was in meters, it's 9 meters above the ground. Easy as from looking at the graph. It says, how long does it take the ball to hit the ground? Well, remember, y is the height above ground. So it hits the ground here when y is 0. This is ground level, the x-axis. And you can see that that happens when x is 5. So that means it hits the ground when x is 5. X was seconds, so it hits the ground after 5 seconds. Okay, how easy was that? After we drew the graph, it was really easy to answer the 2 questions. All right, this has been the luckiest maths teacher in the world. Hope you've enjoyed this video and have a great day.